Have you ever wondered how your phone, your tablet, or your computer actually understands you? Because here's the wild part. They don't get words, or pictures, or games. Not really. Turns out, they only understand two things, the number 0 and the number 1. That's it. And somehow, from just those two simple numbers, our entire digital world is built. So while you're scrolling through beautiful photos or playing this incredibly detailed game, what your computer sees is just a ridiculously long string of zeros and ones. It seems kind of impossible, doesn't it? How do you get from one to the other? Well, let's dive in. This secret language of zeros and ones is called binary code, and over the next few minutes, you and I are going to crack it together. So the secret to understanding all of this starts with the absolute simplest idea you can imagine. Just think about a light switch. When that switch is off, there's no electricity flowing. We can just call that state 0. It's a clear signal. It's off. Simple. And you guessed it, when the switch is on, electricity is flowing. We'll call that state 1. Again, super simple. There's no maybe. There's no sort of on. It's either off or on, 0 or 1. Each one of these little switches, each single 0 or 1, is called a bit. It's the smallest possible piece of information a computer can handle. Now, of course, your computer doesn't have actual light switches inside. Instead, it has billions of microscopic electronic switches called transistors, but they all work on this exact same simple principle: on or off, 1 or 0. So a single bit by itself isn't all that useful. The real magic, though, happens when you start stringing them together. And believe it or not, you can actually count in binary right now, just using your hand.
Come on, let's try it.
Okay, hold out one hand. Each finger is a bit. A finger down is a 0, and a finger up is a 1. Now here's the pattern. Each finger is worth double the one before it. So your pinky is worth 1. Your ring finger is 2. The middle is 4, the index is 8, and your thumb is 16. So if you wanted to make the number 3, what would you do? You'd raise your ring finger, which is 2, and your pinky, which is 1. 2 plus 1 equals 3. Now check this out. With just one hand, you can count all the way up to 31. But with two hands, that's 10 bits, you can represent any number from 0 all the way up to 1023. That's the power of this system. Okay, so we can represent any number we want with enough ones and zeros. That's cool. But what about everything else? Like letters, symbols, or even pictures. This is the next big leap, right? How do you turn the symbol for the letter A into a bunch of on and off switches? Well, the answer is surprisingly simple. We just agreed on a code. Decades ago, computer scientists created this universal chart called ASCII. The best way to think about it is like a secret decoder ring that everyone in the world agreed to use. So here's how it works. In the ASCII chart, the capital letter A is assigned the number 65. And as we just learned, any number can be written in binary. Well, the number 65 in binary is 0100001. So when you press the A key on your keyboard, it sends that exact sequence of ons and offs to the computer. It really is as simple as that. It even works for pictures. This is so cool. Look at this grid. Imagine each square is a tiny pixel on a screen. We can just decide that 0 means the pixel is off, so it's white, and 1 means the pixel is on, so it's black. If you follow that rule and color in every single square that has a 1, a shape appears. This is exactly how your computer builds complex images, just with millions more pixels and a few more bits to define all the colors. This might lead you to a really good question. Why stick with just 2 numbers? I mean, wouldn't it be more efficient to use a system with, say, 10 different levels of electricity to represent the numbers 0 through 9? It's a great question, and the answer gets right to the heart of why computers work so well. The reason is one word: reliability. See, in electronics, signals aren't perfect. They get weaker, they run into interference, they're affected by heat. In a simple on-off system, even if that on signal gets a little weaker, it's still clearly on. But in a system with 10 levels, a signal for the number 3 could easily get a little weaker and be misread as a 2. And when you're doing billions of calculations a second, one tiny error would cause total chaos. An old engineering professor put it perfectly. You can instantly tell if a wall socket is on or off, but telling the exact voltage, that's way, way harder.
Computers need absolute certainty, not guesswork.
So the binary system wins because it is incredibly robust. There's no confusion, there's no maybe. It's a system built on certainty. It either works or it doesn't. And if you're building a machine that has to perform trillions of flawless operations, that is exactly what you need. So there you have it. The secret is out. We've officially peeked behind the curtain of our digital world. Every time you send a text, watch a video, or play a game, what's really happening is that billions of tiny little switches are flipping on and off at incredible speeds, speaking that simple, powerful language of zeros and ones. It's really amazing to think that all of that complexity, our entire modern world, is built from such a simple foundation. The code isn't a mystery anymore, so the only question left is, what do you want to build with it?